Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to continue on with the periodic trends, and so we're going to be talking about the periodic trend of electronegativity. So let's get into this. So as we've been saying before, or as I've been saying before in my previous videos, the key to understanding the trends is to see what's going on with the nuclear charge, what's going on with the size of the atom. So let's go look into this. So if we're thinking about this, what's going on with nuclear charge, as we saw, the effective nuclear charge of the atom is getting larger as you go across. And that's because the nucleus is getting bigger, the shielding is staying the same. And so the electrons on the outside are going to be feeling a larger force that's going to bring them in closer, and so the size of the atom is increasing this way. So we're thinking about that strength of that force on the electrons. And as we're going down a group, so here we see that as we're going down the group, we're adding an energy shell. The shielding increases, but the number of protons in the nucleus increases, but they both cancel each other out. So the total effective nuclear charge stays about the same. So here we're looking at the size of the atom, how far that valence electron is from the nucleus. So if we keep in mind that the farther the electron is from the nucleus, the weaker that attractive force, that'll help us think about electronegativity. And if we're thinking about the effective nuclear charge, the stronger that charge of the nucleus that the electrons are feeling, then the stronger that force is going to be on the electrons. So that's what we need to keep in mind. So what is electronegativity? Electronegativity is a measure of the ability of an atom in a chemical compound to attract the electrons from one atom in the compound, from another atom in the compound. Okay, so to put that in more layman's terms, we can basically say that it's how strongly can one atom pull on the electrons being shared in a bond. So here we have an example. I have hydrogen and chlorine. So hydrogen and chlorine are sharing these two electrons. That's binding them together. So they're bonded together by these electrons that they're sharing. So electronegativity is a measure of how strongly each of these different atoms are going to be attracting and pulling on these two electrons. So which one is going to be pulling harder on the electrons? Is it chlorine or is it hydrogen? That is electronegativity. So if chlorine is more electronegative, that means that chlorine would be pulling on those electrons more than, say, hydrogen. If hydrogen is more electronegative, then hydrogen would be pulling on those electrons more than chlorine. So we're focused on the electrons in a bond, the electrons that are being shared between atoms in a molecule, for example. All right, so now that we kind of understand what electronegativity is, it's that strength or measure of how strongly the electron, how strongly that atom is going to be pulling on those electrons in a bond. Then we can look at our trends. So if we remember that the effective nuclear charge is increasing this way, and what that means is that the nucleus is pulling more on the electrons, right? These valence electrons. And guess what? The valence electrons, by and large, are the electrons that are involved in bonding, right? So we're talking about the pulling on those valence electrons in a bond. So it's just that those valence electrons are being shared between the two atoms in a bond. So if we're thinking about the strength of that pull, then when we consider the fact that the nuclear charge, the effective nuclear charge of an atom is increasing this way, and that means that the pulling and the attractive force is going to be stronger as we go across this way, then it makes sense that if we're talking about the attractive force on the electrons in a bond, then of course the atom that has the stronger pull, the stronger effective force, is going to be the one with the higher electronegativity. And so therefore, we would expect, and this is the case, that electronegativity increases going across the periodic table from left to right. And again, that follows the increase of the effective nuclear charge, that strong, the attractive force, that pulling of the electrons by the nucleus. Okay, so stronger attractive nuclear force, stronger effective nuclear force means more pulling of the electrons in a bond. Okay, so more electronegative. So what about going down a group? As we said, so as you go down a group, the effective nuclear charge stays the same, but look, the electrons, the valence electrons are getting farther from the nucleus. So again, that distance is increasing, and therefore that attractive force by the nucleus decreases as well. And so there's going to be less of a pull on the electrons by the nucleus because the valence electron is farther away. So what does that have to do with the pulling of the electrons in a bond? Well, if the pulling of the electron, if the valence electrons are the electrons involved in the bond, and the farther away, the bigger the atom, the farther away that the valence electron is for this particular atom, then that means that it's going to have a weaker pull. So the electronegativity we would expect would be lower. So larger atoms, electrons, the valence electrons are farther away, therefore less attractive force, not as a strong force. So when we're talking about the electrons in a bond, then the bigger atom is not going to be pulling on those electrons as much. So therefore, we would predict that going down a group, the electronegativity decreases. So, and that's the trend. So the trend of electronegativity is increasing across the periodic table left to right, decreasing down a group, or increasing up the group. So if we write this in our periodic table, my rectangular periodic table, then we would see the trend this way. So if you're going up, then I'll put En for electronegativity. Electronegativity is increasing going up the group, and it increases going across left to right. So electronegativity increases. So then the general trend in the periodic table is increasing from this corner to this corner. So electronegativity increases. And that, ladies and gentlemen, is the pattern of electronegativity. I hope this was very helpful. I hope enlightening, and you learned something from my video. If you did, smash that like button, share the video with others. Please subscribe to my channel, hit the notification bell so you can be notified by other videos I put out. Put a comment in the comment section. Let me know what you think and ask me any questions. Thanks for joining me. Have a great day.